So this lesson is titled What to Think When You See That Opening Curly Brace. And as I'll mention at the end of this video, this discussion is going to be about pattern recognition. So what I'm trying to do is get you to understand when you see this code right here, you can quickly recognize, oh, okay, I know what that code is. Or if you see code like this, you can also say, oh, okay, I know what that code is as well. And if you already know those things, that's great. Turn off this video, go ahead and go on to the next video. But if you look at this code or this code and there's a little bit of confusion in your mind, that's what this lesson is going to be, is trying to explain what these things can possibly be and what they mean. And the short answers I have for both of these is that when you look at this code right here, that can be one of two different things. It can be an anonymous class, and actually that's not 100% true, and I'll show you why. So really, it's much more likely to be a function that takes a by name parameter. And this is really the correct solution here. And again, I'll show why in just a few moments. And then if the code is slightly different and it looks like this, then foo can either be a class that takes a function parameter or a function. This is wrong over here. This could be a function that takes a function parameter. So either way, it's going to be one of these two. It's actually going to be much more likely to be a function that takes a function parameter. And I'll show you what that means very shortly. So what I showed you earlier is that I wanted to look at this pattern right here, and I said that this could possibly be an anonymous class. That's actually a mistake because that would require the new keyword right here. So I'm going to copy and paste some code in here and demonstrate what I mean by that. So the way this could be possibly implemented, this right here, is most likely it's going to be a trait like this. So it's going to be a trait that has two abstract members, name and age, and then it has this concrete one, toString right here. And then once you have that, then you can type in the Mary portion of it like that, and that will work. And if I go back here and I take that new out, then you will see that that will not work. So you actually get this error message, not found person. So even in Scala 3, this won't work, and you would need the new keyword. So I'm just going over this one really quick, and I probably should have taken it out of the book. So again, I said this could be an anonymous class. It can't really be an anonymous class because there's no new keyword right there. So what it is, it's going to be a function that takes a by name parameter. And here I show that in this section right here. And I've talked about this in previous videos. So if you've already seen my timer function in previous videos, or if you saw it in my other books, then there's no real need for you to watch this portion of the video. So feel free to skip ahead. Otherwise, I'm going to discuss the timer really quick. And this is the way the timer works. So it is a function. I haven't shown it yet, but it's a function. And it takes this code block in right here. So the code block starts with this left curly brace here, goes down to the right curly brace down here. And then the code that's inside of that is the code block inside there. I call it a code block. You'll actually see there's a more formal name for that. And this one in particular returns two values right here, and it returns the result and the time, and that's a tuple. And I can tell that's a tuple because of that opening parenthesis there on the left and the closing parenthesis there on the right. So this is a two-element tuple is what comes out of the timer function. So I have that defined here. I noticed a little while ago that I didn't do that 100% right. Back in Scala 2, I didn't always show the return type of function, so I don't show that right here. And actually, I'm going to just go ahead and paste that in without the return type right there. So I don't have a return type on my function. I will add it in a few minutes. But what you can do is just kind of run this real quick, and you'll see how it works. And you notice that it paused for about a second there. So the way it works is that, again, this code right here is a tuple. I'm expecting a two-element tuple to come out of the timer function. And what I do is I pass in this block of code from here to here. I pass that as a call by name parameter into the timer function. So now that I've just told you this is a code block or a call by name parameter, when you go back and look at the function definition, you should expect to see this type of syntax right there. And that's what we use for a block of code, or again, more formally, it's called a by name parameter or a call by name parameter. And you can see it takes something, I've named the variable name block of code, and it transforms anything on the input side over here into the generic type A. So what that means is it can take any type of block of code inside here. So you could even type in something, I'll just put like hi mom as a comment there, and then we could just do high there as well. And again, you'll see it sleeps for about a second and it returns high. So in this case, it returned an int. In this case, it returns a string. And that's because the block of code is defined to return any generic type right there. So again, the key for this portion of this lesson is when you see this type of code here, you see an opening curly brace, and then there's nothing over in this area right here, you can expect that you're going to find a block of code inside of here. And more formally, that's known as a by name parameter. And now what I want to do, that was the lesson portion of this. And now what I want to do is correct this very quickly because I should have shown like this, that this function returns a tuple type. So when I look at the result up here, I can see that I'm returning result here and then time here. Result is the first parameter, and that's going to be the result of whatever your block of code is. So because that's a generic type, that's an A. That's whatever you're returning out of your block of code. And then the time I return as a double. So that's going to be the type of that second parameter right there. And now when I hit enter, you can see that that works as desired. So all I want to do is kind of correct this portion of this right there. But again, the key for this from a pattern recognition standpoint is when you see this opening curly brace right here and there's nothing right over here, that means you're going to start to be looking at a block of code right here. And now the second pattern that you're going to see is that opening curly brace followed by some type over here. And this could be one parameter here. It could be 2, 3, 4, whatever it needs inside of these parentheses over here. And this is actually a little bit different. What this is going to be is one of two different things. It's either going to be a class that takes a function input parameter, or it's going to be a function that takes a function input parameter. And I'll demonstrate that here next. So in the book, I show something like this. So I created a case class. I call it string to int converter. And what it does, I'm calling this algorithm. Usually you've seen in my past videos, I will call that something like F or fun for function or something like that. But in this case, I'm going to call it algorithm or algo. So I'll just leave that like that. And then what I want to do is show that when you have code like this, what's going on here is I'm creating a variable over here. And I'm saying that's equal to this class, and then I'm passing in, again, the pattern recognition part I'm talking about is when you see this opening curly brace, and then it's followed by one or more input parameters, and then that's followed by this transformation symbol. Now you should be thinking, oh, okay, whatever string to int converter is, it's taking a function input parameter. As soon as you see that right here, you think, okay, this is a function input parameter right here. So now I'm going to finish defining this function. And I could put a comment here. This could be a function that has many lines. And then I'll just say, well, s.length is going to be the actual function right here. And then I'll close that right there. So now what this has done is I created a function that starts up here. This is the input parameter to the function. And then everything to the right of the transformation symbol in here and here is the body of the function. So everything from here to here defines a function. So now this function is being assigned to this algorithm variable there. So now the way that works is you have this variable right here, and it has the algorithm parameter right there. So now what you do, and again, algorithm is a function. So what I want to do now is call that function. And when I call algorithm, you can see that it expects a string input parameter. So I'm going to give it a string, and we'll just give it something like banana. And then we see the result. So that's kind of cool. It's one of the nice things about functional programming languages is that you can define a function like this. You can store it in a function parameter. And then sometime later in your code, you can call that function. And when you call it, you just need to pass in whatever it's expecting. So in this case right here, you can see that it's expecting a string input parameter. And you can also get that same information from here. You say, oh, okay, it's expecting a string input parameter. So when I give it a string right here, it's going to go ahead and run its algorithm and give me the result from that algorithm. And then as a second example, I can copy and paste some more code in here. So in this case, I passed in a function, and this one is called count vowels. And the purpose of it is to count the vowels in the string that's passed into it. And it returns that as an int. So the way you do this is you create a set that contains all the vowels over here. I call that vowels. And then when this code right here, what you're doing is you're treating the string like a sequence, because really a string is a sequence of characters. And if I go back there, I can make that a little bit more obvious and say, for each character C, check to see if the vowels set contains that character C, like that. So if I didn't say that right, let me do that again. So again, we're treating S as a sequence of characters. We're calling the count method on that sequence, and then we're passing in this anonymous function. So as it's marching through this string right here, we say for each character C in the string, if the set vowels here contains that current character, then return true right there, and then that will count that. So the way that would work, we could say count vowels would be something like, I could just do A, B, 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 like that, and you'll see that that works like that. So that's how count vowels works on its own. But now the other thing I can do is come back up here and say, well, if I wanted to, I could create this again. So let's copy that and paste that here. And again, you should be thinking in your mind as soon as you see this, oh, okay, we're creating an anonymous function over here. So this could be multiple lines and something like hello right there. And then what I could do inside of here is call count vowels. And then we'll apply that to that string S that we're given and save that. So again, just as a quick review, I just created this anonymous function from here to here, and that anonymous function was assigned to this algorithm variable in this class right here. And now all I have to do is on this variable right here, I call algorithm, and then I pass in the string that I want to. So it could be C, C, E, E, something like that. And then in the end, we get the count of the vowels being 5. So again, no matter what functions I do, the key for this lesson is this pattern recognition part. And that's that when you see this opening curly brace followed by one or more parameters right here, and then that's followed by the transformation symbol, immediately in your mind, you should start thinking, oh, okay, we're defining an anonymous function here. And that anonymous function is going to need to have a string passed into it later. That's what you should be thinking as soon as you see this code right up here. And now this next part, as I mentioned, this is a class that takes a function input parameter. And if I scroll down here, this could also be a function that takes in a function input parameter. And I'm not going to get into that too much here in the REPL. I'm just going to kind of walk through this code a little bit here. What I do in this case was I am saying, well, what if we had a function named s to I? And this one actually takes in 2 input parameter groups. And hopefully you've seen this in the previous videos, but you could see as soon as you see this opening parenthesis and that closing one right there, you think, oh, okay, this is the first input parameter group right there. And it's a string. So if s to I is a class or if it's a function, this part from here to here is a first parameter group and it's going to be a string. Then there's a second input parameter group that starts with this curly brace and goes down to here. And I can tell from this code all the way through here that this is going to be a function input parameter. And again, that's going to be a function input parameter that takes a string as its input. And then if I go look at the body down here, I could say, well, oh, okay, that's going to have to return an int as its result. And if we scroll down here, we could see, oh, okay, this could be implemented as this function right here. And again, hopefully this is exactly what I just said. We have the function s to I. First input parameter group takes a string. The second input parameter group is a function that transforms a string to an int. And then the body just applies this function here to the string here. And I go on to note, I show the example here. So if you want to type some of this into the REPL yourself, go ahead and pause this video and then you go ahead and do that. I note here that this could potentially be a case class, but I think that's a bit convoluted. And so I'm not really going to get into that too much. So again, if you want to pause the video and take a look at that, it is possible it could be a case class. But I think it's much more likely that s to I in this case, and this case right here, s to I is much more likely to be a function. But I don't want to dismiss it. Could be a case class too. And then here in the book, I get into practical use of multiple parameter groups. So I've talked about this before. I don't want to get into it too much. But again, when you look at like the using control structure, that's actually a really good example of this. So as soon as you see this opening parenthesis here and that closing one there, you think, okay, that's the first parameter group right there. And then now we start the second parameter group and it starts here. And you can see the variable name, the transformation symbol. So you think, oh, okay, this is going to be a function. It's taking a anonymous function that starts from here and ends down right here. So again, for the purpose of this video, that's what I want you to get comfortable with, is seeing as soon as you see that curly brace and this stuff right here, now you're like, oh, okay, what follows here is going to be an anonymous function. And then what's going to happen later is that a source type is going to have to be passed in to this anonymous function for it to run later. And I will take a look at this very quickly because this is really interesting here from a type perspective. So the way using is defined, you see the way using is used up here. The way using is defined is it's a function. And inside these brackets here, from this bracket to here, this is where we define the generic types. So this has two generic types. One is A, the second one is B. And the way you read this first one is that A has to be something like a class that's going to have a close method on it. And more specifically, that close method is going to have to return unit. That's the way you read this generic type A. So the whole definition starts here and ends over here. This isn't used that often, but when you see this, I want you to know that's what that means. So in this case, this is going to be a source data type. And I happen to know that source has a close method defined on it, and it returns a unit. So a source can be used inside of here. And then when we come over here, so again, everything from the left bracket to the right bracket was just a definition of these generic data types. Now here, this is the first parameter group right here. So that's the resource. It's called resource of A right here. And that's going to be this source up here. That's what that is. And the second parameter group is going to be a function, and it transforms the A into some potentially different type B right there. And then when that function runs down here, it's going to return a B from the using function like there. And then what happens in the body here is that the function is applied to the resource. So in this case, this function is going to be applied to the source that it has. And then the finally clause makes sure that when that is done, the resource is going to be properly closed right here. So again, if I go back to the point of this lesson, all I'm trying to show in this particular case is that when you see this pattern right here, you can know that you're starting to define an anonymous function in this code. That's the purpose of this lesson. And then I just got into this because I noticed this code here, and I thought that might be interesting to mention about these generic types right here. So if I scroll back down to the summary down here, the two things I'm trying to show in this lesson are that when you see an opening parenthesis like this, and there's nothing over here, then you can think of this code inside of here as being a code block. And more specifically, the correct name for that is a call by name parameter or a by name parameter. And this is an example of a function here that expects a block of code like that. So this is the first pattern to recognize. And then the second pattern to recognize is this opening curly brace, followed by, there can be one or more parameters here. I've only shown one parameter so far, but there could be multiple parameters in this area right here, followed by that transformation symbol. Then when you see that, you think, well, now this is not a block of code, but this is going to be an anonymous function that is being defined from this opening curly brace here down to this closing curly brace down here. And here I do show another example. So this is an anonymous function that takes two input parameters and then transforms that with this algorithm right here. So that anonymous function is being defined starting here and ending here. And then right here, I show how that's defined. So if you want to pause the video and look at that, you are more than welcome to do that. Otherwise, I'm going to scroll down here. And the reason I wrote this entire chapter and the reason I created this video is because years ago, I was reading a book. It was called The Little Schemer. And the authors noted this, and they said the goal of the book is to teach the reader to think recursively. And then they note that there's their belief that writing programs recursively in Scheme is essentially pattern recognition. And that really occurred to me when I came back to this code. As I mentioned, I'd been away from Scala for a while. And then when I looked at this code, I was like, wow, what is going on in that code right there? And again, that's just pattern recognition. And this specific one is that, okay, there's a block of code inside of here. And then as I noted earlier, when you look at other code like this one right here, then you think, oh, okay, this one's going to be the beginning of the definition of an anonymous function. So in summary, those are the two patterns that I was trying to demonstrate in this video.